Alright, we can observe you descending the ladder at this moment. In July 1969, humanity achieved a lunar landing. That's the narrative everyone is familiar with. However, the Apollo program encompasses far more than that single monumental step. What remains largely unknown is that NASA successfully completed 6 Apollo lunar landings within a mere 3-year period. Consider that for a moment. 6 crewed lunar touchdowns in 3 years, an achievement that would seem impossible by contemporary standards. So what exactly were all these astronauts accomplishing during their time there? Apollo 12, the second crewed expedition to the moon, launched mere months following Neil Armstrong's historic first step. The date was November 1969. Charles Conrad, Richard Gordon, and Alan Bean secured themselves into their Saturn V rocket for humanity's celebrated return to the lunar surface. However, the journey ahead would prove challenging. Apollo 12 carried ambitious objectives. The crew transported a cutting-edge color television camera designed to transmit live footage from the moon, representing a substantial improvement over the grainy monochrome footage from Apollo 11. This expedition also served as a crucial technical validation for NASA. The inaugural moon landing had succeeded, though only marginally. What escaped most people's awareness was that Neil and Buzz had been drifting off their intended course throughout their spacecraft's entire descent toward the moon. They ultimately overshot their designated landing area by several miles, touching down in what amounted to an arbitrary location. Therefore, NASA's objective with Apollo 12 was to demonstrate their capability to land a spacecraft precisely on target. This precision would prove essential for accomplishing scientific exploration objectives on the moon. NASA selected a recognizable target, the Surveyor-3 spacecraft. This robotic landing vehicle had settled onto the lunar terrain just 3 years prior in 1967. The Apollo 12 mission's goal would be to locate and visit Surveyor-3. Regrettably for the Apollo 12 crew, this mission encountered difficulties immediately from launch. Their Saturn V launched amid a thunderstorm. These conditions were far from optimal for launch, yet NASA faced mounting pressure to proceed. President Nixon and his wife had traveled to Florida specifically to witness this launch. Everyone understood that postponing now would delay the next lunar opportunity by months. Consequently, the rocket vanished into the cloud cover above the launch facility. Merely 36 seconds into the flight, at an elevation exceeding 6,000 feet, Apollo 12 suffered a lightning strike. The electrical bolt instantly plunged the spacecraft's electrical systems into disarray. Alert indicators illuminated throughout the instrument consoles. Mission Control lost communication with the rocket, and the 3 astronauts aboard held their breath anxiously. Then lightning struck them once more, just 16 seconds afterward. Now, at an altitude of 14,000 feet, the rocket had lost its primary power source, lost guidance and navigation capabilities, and was hurtling directly toward catastrophe at tremendous velocity. One swift-thinking controller rescued the situation. A flight controller at ground level had encountered a comparable electrical malfunction during a training exercise, and he transmitted to Apollo 12, "Try SCE to auxiliary." That phrase has since become legendary among moon landing enthusiasts. Its effect was to switch the signal conditioning equipment SCE to auxiliary mode, which restored power and enabled the mission to proceed. That marked the final occasion NASA launched a rocket during a thunderstorm. After that near-catastrophic incident, Apollo 12 proceeded to execute an almost perfect landing on the rim of Surveyor Crater, positioned just 180 meters from where the Surveyor-3 spacecraft awaited. On Earth, millions of viewers had tuned in to observe the inaugural color television transmission from the moon. What they witnessed must have presented an awe-inspiring glimpse of the second humans to plant their feet on the lunar terrain. Unfortunately, this broadcast would be extremely brief. Only minutes into their moonwalk, Alan Bean inadvertently directed the television camera straight into the sun. Because the moon lacks an atmosphere, sunlight intensity there is extraordinarily powerful. It immediately destroyed the delicate vacuum tubes within the camera, ending the television transmission. Yet this was nowhere near the conclusion of Apollo 12. The astronauts fulfilled their mission to the Surveyor spacecraft, retrieving several components they would transport back to Earth. These represented the first human-made objects ever recovered from an extended duration in outer space. The Apollo 12 astronauts additionally installed a highly significant technological apparatus on the moon. The Apollo Lunar Surface Experiments package consisted of a sophisticated array of geophysical instruments engineered to continuously monitor the lunar environment following the astronauts' departure. This package contained something designated the Lunar Seismic Experiment, essentially a seismometer designed to detect earthquakes on the moon, or moonquakes. NASA chose to test this instrument by creating a moonquake themselves. After the astronauts had departed from the surface and rejoined the Apollo command module in orbit, their lunar spacecraft was then deliberately crashed into the moon. The lunar seismic experiment recorded the vibrations generated by the impact, and scientists were astonished to observe that the reverberations from the collision persisted for nearly an hour. It was described that the moon rang like a bell, representing a significant initial step in discovering that the moon was considerably more enigmatic than anyone had previously conceived. Apollo 13, an unfortunate number for an unfortunate crew embarking on the first unsuccessful mission to the moon. Approximately midway through their voyage, an electrical malfunction within the Apollo 13 service module triggered an oxygen tank explosion, placing the crew in a potentially fatal predicament. For the third time, millions of people on Earth remained fixated on their television screens, observing a dramatic narrative unfolding in space. This occasion, however, was distinctly different. Every lunar mission had carried inherent danger. Apollo 13, however, made that danger devastatingly tangible. The crew ultimately survived, though there existed a definite transformation in how both the public and the government perceived the moon landing program. That didn't prevent Apollo 14 from advancing as scheduled. This would represent America's triumphant return to the moon, arriving almost 1 year following the Apollo 13 incident. To command this critical mission, NASA would summon an American hero from the space age, Alan Shepard. The first American to reach outer space was now preparing to walk on the moon. At 47 years old, Shepard was the eldest Apollo astronaut, though his experience would contribute critically to Apollo 14's success. As had become customary by this point, the crew experienced a crisis during their journey to the moon. When the Saturn V rocket launches, the lunar lander travels secured inside a payload fairing beneath the crew capsule. However, to position the lander properly for the crew to transfer over and descend to the moon, the command module must separate from the lander, rotate around, and dock the nose of the capsule into the lander's airlock. This procedure had to be executed manually by the command module pilot with electronic assistance from a docking probe. When Apollo 14 attempted the docking procedure, the command module failed to secure onto the lunar lander. They attempted again 6 additional times without success. This complication might have cost them the moon landing, but Commander Shepard maintained his composure. He deactivated the electronic probe and instructed the pilot to execute the docking visually, like Luke Skywalker navigating through the Death Star trench, and it succeeded. The Apollo 14 moon landing would achieve the most accurate touchdown yet, positioned just 87 feet from the designated target. Alan Shepard may not have been the first human to walk on the moon, though he would become the first to play golf there. Before the mission, Shepard had arranged for a 6-iron club head to be attached to the end of his lunar sampling instrument. He then succeeded in bringing 2 golf balls with him all the way to the moon's surface, and standing directly before the live television camera, Shepard prepared himself and executed his first swing. The spacesuit restricted him from using both arms, and following one mishit, he managed to connect solidly with the second ball, sending it soaring across the lunar surface. Shepard asserted that the ball traveled for miles upon miles. Realistically, it covered approximately 40 yards. That moment of lightheartedness was precisely what America required at that time. Apollo 14 restored faith in NASA's capability to land on the moon, setting the foundation for a substantial advancement in lunar exploration that was approaching. Apollo 15 represented a transformative expedition regarding moon exploration. NASA had incorporated everything they acquired from the initial 3 lunar landings and enhanced their technology for extended duration stays on the moon and improved geological investigations. Astronauts could now invest a complete 3 days exploring the surface thanks to an upgraded life support system aboard their lunar lander. To maximize that extended stay, NASA provided them with the new Lunar Roving Vehicle, a battery-operated electric dune buggy featuring a maximum speed of 15 kilometers per hour with a range of approximately 90 kilometers on a single charge. Utilizing the LRV, Apollo 15 astronauts investigated mountain ranges and ancient lava flows across the moon's surface, recovering an item that would become known as the Genesis Rock, a stone dating back 4.1 billion years to the early period of our solar system. The crew also seized their opportunity on the moon to demonstrate Galileo's theory of gravity by releasing a feather and a hammer simultaneously. During the 16th century, the astronomer Galileo would drop objects from the Leaning Tower of Pisa to illustrate that objects of differing weights will descend at identical speeds because the force of gravity remains constant. The sole variable affecting how rapidly things fall is air resistance. Therefore, on the moon, in the absence of air, the feather and hammer descended at precisely the same speed. 10 months later, In April 1972, Apollo 16 would reach the moon, transporting with them the now validated lunar roving vehicle on a mission to investigate the lunar highlands, believed to be the location of significant volcanic activity during the moon's distant past. Notable crew members of Apollo 16 included Charles Duke, who had participated in the very first moon landing but remained in the Apollo capsule while Neil and Buzz descended to the surface. Now it was Charles's opportunity to pilot the lunar lander and create his own footprints on the moon. Paradoxically, what the crew discovered was that the Highland D region wasn't formed by volcanic activity whatsoever. Their investigation revealed that the terrain had instead been elevated by massive asteroid collisions. This represented a tremendous milestone in advancing our comprehension of the moon and its formation process. Another intriguing discovery from Apollo 16 was the crew's observations regarding the taste and smell of moon dust. They reported that it felt oily against their skin and possessed a scent that reminded both men of gunpowder. In December 1972, the time had arrived for the ultimate moon landing, Apollo 17. Unfortunately, by this stage, both the public and political leaders had lost enthusiasm for lunar exploration. That didn't deter NASA from assembling the most scientifically and technologically sophisticated human spaceflight ever undertaken. That distinction remains valid to this day. Apollo 17 represented the first and only occasion that a scientist would walk on the moon. Every Apollo landing had performed scientific investigations, though every previous astronaut had been an Air Force jet pilot who received scientific training. Harrison Schmitt was a professional geologist who had been trained to function as a lunar module pilot. Apollo 17 touched down in a lunar region designated the Taurus-Littrow Valley. The landing location was encircled by low mountains featuring steep cliffs that revealed ancient rock from within the lunar interior. This mission remained on the moon longer than any other, with Schmitt and his commander spending 75 hours on the surface. Of that duration, 22 hours were devoted to extravehicular activities. Once again, the rover fulfilled a vital role in exploring the moon. The astronauts would traverse over 36 kilometers of the lunar terrain and reach distances exceeding 7 kilometers from their landing site. Among the more fascinating discoveries they made was that the moon isn't entirely gray and devoid of color. Schmitt uncovered what appeared to be orange soil concealed beneath the outer layer of dust. When the orange soil underwent examination on Earth, they determined that it was actually filled with brilliantly colored spheres of volcanic glass that had formed 3.6 billion years ago. In total, Apollo 17 successfully returned 741 individual rock and soil specimens, totaling 110 kilograms, representing the largest sample return of any lunar mission. These specimens would establish the foundation of our present understanding regarding the moon's volcanic history and the formation of the early solar system. By this point in history, NASA was fully cognizant that the Apollo program had reached its conclusion. While optimism persisted that human beings would return to the moon's surface at some point in the not-so-distant future, it was acknowledged that Apollo 17 marked the end of an era. Mission Commander Eugene Cernan would become the last person to stand on the lunar surface. In his closing words before returning to the spacecraft, he stated, "With peace and hope for all mankind,